Okay, hi guys. So in this lecture, we'll be continuing on seeing the reaction of acetal and hemiacetal, and when we are passing acidic medium over them. Okay. So next example is we have this is not exactly an acetal. We are just seeing the reaction of concentrated HI over this substrate. So what would happen? What would be the product? The product would be simply we would have OH here with 2 CH3I released. Okay, so I hope you can imagine the mechanism. So plus positive sign cannot be occurring here because of the formation of aryl like cation, which is highly unstable. Hence by SN2 I minus will be actually attacking on CS3 to get it converted into 2 moles of CS3I, and H would be attacking onto the O atom. H would be attaching onto the O atom. What about this? We are passing in concentrated HI and that too in excess. So what would happen is we would have I here and CS3I. I hope you are getting why are we getting CS3I here, because initially it would be removed at CS3OH, but due to excess of HI, this again would be converting into CS3I, and H2O would be also formed. Okay, and in this case, why is the reaction going into the forward direction? Obviously because I minus would be more nucleophilic in polar protic solvent than OH minus, because OH minus would be having more would be more hydrated, okay, due to its smaller size. Third example is we have something like this. So what happens here is we have concentrated HI and in excess. So what will happen here is again we would have the OH would not be different, but we are also getting 3 moles of CS3I, because CS3OH will be getting converted into CS3I plus water. Okay, what happens in this case when we have this and in concentrated HI we would be having something like this. Won't be getting any positive charge. The positive charge would be here only, and this positive charge would actually be attacked by I minus. Okay, so the resultant product would be OH here and I here. Okay, and this would take place via SN2 mechanism. Why? Because this is just a 1 degree carbon atom. So on 1 degree carbon atom, the attack of nucleophile is necessary, and the formation of carbocation would not take place in the intermediate. Okay, we have something like this O18 C and CS3 and CS3. So what are the products when we actually have the reagents as concentrated HI on one hand and anhydrous HI on another hand? So what would happen if we take concentrated HI? It is actually a solvent. Okay, so we would have product something like this plus I here. Okay, because of the formation of free radical on carbocation, so it would take place via SN1 mechanism. And on the other hand, we don't have a solvent because we are just having ions in the form of H plus and I minus, because it is anhydrous. Anhydrous means devoid of any solvent. Okay, or basically hydro word is attached to water, so it is devoid of water. So water was actually the uh, solvent in our case when compared to HI. So water is not there, simply HI is there. So what will happen in this case? No formation of carbocation will take place. Instead, we will have something like SN2 mechanism, wherein I minus will be attacking on the less stereogenic area, which is CS3. So it would be forming CS3I plus. Obviously, O18 plus H would be there formed in the first step, and in the second step, I minus would be attacking on CS3 because it is less sterically hindered than this carbon. So we would have O18H and C this, and this will take place via SN2 mechanism. So these are the different products will be formed. Okay. Let's take a look at this example. We have, and we take HI. If I don't write anything before HI, it means it is in concentrated form. For anhydrous, I have to specifically mention there it is anhydrous. But if I don't mention anything, that it is but understood or well understood that it is concentrated form only. So in concentrated form, formation of free radical will take place because this is more stable. So on this, our I minus will attack, so we would have something like this, and obviously CS3OH should be formed. If had it been in excess, this would also be converted into CS3I, but it is not mentioned in the question, hence this would be our final product. Had it been mentioned excess here, then this would be the product, side product. Okay, and this obviously takes place via SN1 mechanism. Why? Because free radical is stable because of the plus M effect of phenyl group on the attached CS2 plus. Okay, so next you have to write the mechanism of the following. Write mechanism. So we have this structure, OCS3 and OCS3. It is passed on with 5 moles of HI. What will happen in the first step? Obviously this and this will attack on 2 moles of HI to form something like this, and 2 moles of CS3OH will be formed, and now we have only 3 HI left. So what will happen is, next 2 HI would be used here to form 2 moles of CS3I. Okay, so we have consumed 4 moles of HI. Now we have only 1 mole of HI left. So what will happen is this, if you these are the 2 bulky groups. Okay, and I minus is also a good leaving agent. So what will happen in this case is, as the delta H of this reaction is negative, this step is negative, it will have form a double bond on the cyclohexene ring, or a cyclohexene ring will be formed with a release of I2, and on this cyclohexene ring 1 mole of HI will again react to have a nucleophilic addition reaction or electrophilic addition reaction on this. So what will happen is, this double bond will actually take up hydrogen to form a positive here and hydrogen here, and this will be further attacked by I minus to form this product. This product. Okay, so please remember that in case of vicinal dihalide or vicinal diiodide, II and combines each with each other to release and to form a double bond in the cyclohexene ring. Okay, and the reason of this is the carbon iodine sigma bond is weaker than pi bond of alkene. So the carbon iodine bond is weaker than carbon iodine sigma bond is weaker than pi bond in alkene. Okay, so again let us look at this example where we have this as the substrate, and you have to determine the value of X moles of HI that should be taken up to form something like this plus CS3I, 2 moles of CS3I. So how many moles of I would be used? This is the question. So in this you can see that the 2 moles are initially required for these two oxygen atoms to convert themselves into CS3OH. So we would have something like this plus CS3OH, 2 moles of CS3OH. Now for this to convert into CS3I, 2 moles of CS3I, we again need 2 moles of HI. Okay, and now as these two are good living groups and delta H is negative to convert it into this double bonded alkene rather than having a two single bonds, this will again we need to have 1 mole of HI for 1 mole of HI is required in this case again to have electrophilic addition reaction on the alkene, and this would be finally produced. And total how many moles of HI did we use? 2 plus 2 plus 1, 5. So X is 5 in this case. Okay, let us see the last example where we have OCS3 and OCS3 here. And X moles of HI would be used here to convert the substrate into a product like this plus 2CS3I. So what would be the value of X here? So X would be 2 here. Why? In the first step this would not be leaving as the carbocation because of the formation of highly unstable aryl cation. So this would be formed with the release of 2 moles of CS3OH, and to convert 2 moles of CS3OH into 2 moles of CS3I, we would need 2 moles of HI. So X in this case is 2. So with this we come to the end of this lecture series on organic chemistry. So we'll be taking another course on further continuing this whole package. So since I hope you enjoyed this video lecture series, please do remember to revise all the videos, make notes out of them, make short notes, summaries, so that you are able to revise the concepts and examples better. Make note of important examples that you are not able to solve in the first go. So I'll be meeting you in the next series of video lectures. So till then, good luck and goodbye. Happy preparation.